Well, in this type of problems, water droplets are falling from a roof. When the nth ball is about to drop, the first ball would have reached the ground. Generally, frequency of drops falling, that means how many drops are falling, etc., positions of the drops, separation between the drops, etc., are to be found out. The general equations are like this: the time interval between the drops, the locations of the drops, etc., are given here. But how to get these equations? Let us see. So, from the roof, water droplets are falling. Let us assume that the first droplet is reaching the ground when the nth droplet is about to fall or say get detached. This is the second one, this is the third one, etc. Now, let us see what is the total time taken by a drop to reach ground. This is given by h is equal to ut plus half at square minus h is equal to u is 0 minus half gt square. So, the time taken is 2h divided by g under root. This is the total time taken by each drop to reach the ground. But this contains multiple intervals, time intervals. How many intervals? Number of such intervals is equal to n minus 1. There are n droplets, n minus 1 intervals. Therefore, the time between two droplets t is equal to total time divided by number of such intervals, that is 1 by n root of 2h divided by g. So, this is the time interval between two successive droplets, 1 by n square root of 2h divided by g. Now, how to find out the positions? Where is the first droplet? Where is the second droplet, etc. Now, suppose I consider the first droplet. First droplet will reach the ground. It would have reached ground, that's right. And where is the second droplet? It would have traveled for a time t. It would have traveled for a time t. So, this is going to be s is equal to half gt square. So, we can write like this: n is equal to, or Sn minus 1 is equal to half gt square, Sn minus 2 is equal to half g into 2t square, etc. Sn minus 3 is equal to half g 3t square, etc.